Now I can show you on the screen that with extra here, you can do extra installer and open the extra folder. So to install, just click on this extra and select extra installer. And you can see that the pop-up from the extra website. And usually we work on the data. You can see so many data. So just for this tutorial, we're going to use this digital rock data. And you just click to install it. And after install, you can open the folder. Yeah, it's very important to know that if you do any modification, like if you copy the local file to this, it will mess up with all the paths. So don't do anything, don't move or even add anything to this folder, because you're gonna mess up with the local folders. So you have this tutorial data that we can use. Yeah, sure. Just to make sure that people know how to use it. Yes. Yeah, definitely. I think when they release it, I'm not sure about this like subscription, how they will convert it. Yeah, I think it's mostly with the marketing, strategic marketing, and licensing. Yeah, I will discuss that. Come back to you. Or let's say we are. Yes. Yes. Yeah, sure. In the segmentation workroom here, so we call it segmentation plus workroom. We have all the automatic segmentation tool we call advanced tool over here. And we used to have the patch tool, but now we don't have patch tool anymore, but we have the raw set. let's say if I open something quickly. Here, go to segmentation. So you can see here, if I would like to do some AI assisted segmentation, we should create a new ROI set. And with the ROI, then you can define the ROI region. So you can select to create a label here and the ROI over here, and you can go to start to create ROI that way. So they remove something that you don't need it anymore, so create a new one. As you can see, you can define region where you want to do segmentation. So for example, you want to create the over here. For deep learning, so you get this annotated data in the ROI, and you can use this for AI assisted segmentation. Here, add to label, and now go to here. So we have the AI. You can add, create many, yeah, and you can do multi-class segmentation. For example, I want to segment two materials like this, and create another segmentation for here. This one, and then add this to material. So now I have two regions to be segmented, and then you can do multi-class segmentation. You can select the model that you already trained, but you can also just run it first, and you can just select the output table. Yeah, and then from this result, it is not this version is not ready yet, but what you can see later that you don't have to install the Python environment anymore. It will be embedded available, so it's much easier. So you can just use the embedded Python environment. So this is much easier than before you have to install the environment. Yeah. So a few things. So this AI assisted segmentation is deep shallow network. So it's not it's shallow deep learning. It's not the real deep learning. So it have a few layers, and make it easier for annotation and segmentation, and try to put all the two together. For example, you can select the object. I showed to Ronell yesterday that can easily select group of the rock or material, and you can manually edit it. But you can still, for example, if you would like to still using the patch tool that I showed for us, and keep the older version like 2023 for you. Yeah, so you have two options. Yeah, they said with the ROI gonna be much easier or more effective than the patch, but you're not convincing. Today we're gonna work on to create data map for finite element analysis, and then we do Pore network modeling and do simulation. Then we can go quickly back to the Pore profile to see the reporting. There'll be a lot with the simulation. Mm-hmm. Mm-hmm. Yeah, yeah. So I will also discuss with the R&D because I see exactly when you merge it, they start to have. Yeah. So maybe we can discuss later. Would be... So you found a way on the reconstruction? You okay? Sure. Okay. So yeah, let's start from the matching workroom. So open Avizo and just select to open data. So by default, it should point to this data folder. Okay, so when you open the Avizo software, you can see this project workroom over here. Yeah, this project workroom. And you can select to open data over here, or you can go to File, Open Data. And you can see that it will point to this folder, the Avizo tutorial, data tutorial. So we're gonna select the, let's go back for one up. It should point to Avizo and data. So we're gonna work on the tutorial data. So you just have to locate the tutorial over here. Double click and you should see the matching folder. And in matching workroom, we're gonna select the kernel corn dot labels. So you can see the root over here, data, tutorials, matchings, the folder. And then finally select kernel corn dot label. It's already prepared label image for start to work on the matching workroom. It says okay. Everyone can see it. So open it. To forward. Unit, it doesn't matter here. It depends on the voxel size. So it's set to 0.1 nanometer. Yeah. To change the voxel size, if you know that your voxel size is not correct, you can click on the data. And here you can see this crop editor here that you can change the voxel size. When you click on this crop editor side, the crop here on the property of the dataset, you can change this voxel size. So by default, it's 0.1 nanometer. And also it depends on your unit here as well. So if by default you set to micrometer or millimeter, it will be changed accordingly. So if your voxel size is not correct, you can just adjust it, the voxel size. Just not adjust anything. So you see that by default it's nanometer. You can change to, for example, micrometers, and you can see that the unit will change accordingly. Just make sure that you work on the unit. The right setting. Okay, I will repeat one more time. Can you open the data? I will show you how to open. Just click open data, and in this folder, so it should be in data, tutorials, matching workroom, matching folder, and just select this file, kernel corn labels, the one that we need to to work with. Click open. Once you open the data, you can see that by attach auto slide, it is not automatically attached, so you can do right click and select from the drop down here like auto slides, or you can type in the search term auto slides. That's where you can find the viewer for the anything that you can attach. And you can see now because they have different migration from the rendering engine, so you can see different viewer on LDF format or on auto slide. Even it's the same thing, but because it's from different rendering engine that I bought it from PerGeos. Okay. So this is already prepared the label image. So it's not grayscale anymore, as you can see on the thumbnail over here. You can see that they have 3 materials. So the 0 is background, and 1, 2, 3, 1 light blue, and the second one is the darker blue, and then the material 3 is gray. So this is prepared data. So we're gonna work on this data and then create image on this, export for further solving on the solver. So you can quickly add, for example, volume rendering. So you right click and select volume rendering, or you can just click by default if they have something up here on the top that you already can use it. So this is the object, and just to visualize them, you can also look at auto slides and add auto slide on the top right of the property part of the auto slide over here. You have a clipping function as well, so you can clip the inside of the auto of the object. So we have 3 because thing is hidden here. If you don't want to use auto slide, you can also use clipping plane like yesterday. So right click and support type clip clipping plane. So you can see the clipping effect by clip here. So you can see that when you clip, it clip one direction, and you can clip them, you clip again. So change orientation of clipping. The clipping plane, you can see it's just transparent clipping. But auto slide, it just they also show what in auto slide. You can see the background, everything is not transparent. You see the auto slide clipping, you see the background is by default is at the padding to 0 value, so it's black. But if you look at the clipping plane, it's just transparency cutting. And for example, if you use auto slide clipping, you can change the color map of auto slide as well. So you can change to other color. So the clipping is different because now you just see overlay of auto slide clipping on the original data. But if you just use the clipping plane, it's just and after clipping, you can still use translation to look at this object. Okay, that's pretty much to understand the data set. So they have 3 layers, 3 materials. So now we're gonna work on the dedicated matching workroom. So I can just remove everything, so you can see that you can drag around the object. You don't need and press delete button from the keyboard. To start to generate mesh, just select this matching workroom over here. So it's the 4th tab on the top menu. Pardon? Yeah, exactly. So it's a dedicated workroom to create a mesh. So if you click on it, you can jump into the new workroom to create matching. Yeah. This is okay? Everyone follow? So any questions so far? So you can see that in matching workroom we have similar settings. So on the left, sorry, we have the mesh panel, and on the right you see the viewer for the mesh. So start from the mesh. So we don't have any mesh generated yet. And you can see that once you generate mesh, the mesh will appear here. But at the moment, we don't have any mesh generated. And after you generate mesh, I'll explain later how to export it. So in the lower section, we have matching and boundary. That first focus on the matching itself. For matching, to start using the match, to create match, we need to load the prepared data, where you can see that they have input the label data. That's why we load the label image. So if you have the grayscale, first you need to do segmentation, to do, for example, auto thresholding, multi thresholding, any threshold to create the label image. And once you have the label, so this is be ready to create match. So the data that I open here, so it's just the label with 3 material, but you can create multi-materials or even the single material. Here 3 multi-material, just to give you an idea of how it works. And again, back to matching workroom. So first, load the label data. Click on this label data here, and then from drop-down menu, just select. We have only one. Anyway, it's really easy to work with. So select the canacon.label. And now come to see this global parameter. So we have now 2 approaches. You can see that the approach to create mesh, they have polygonal approach and direct approach. Before we have fast and advanced, but now we change completely. So what's the difference between polygonal approach and direct approach? So for direct approach, we're gonna generate mesh directly from the label image. So it's gonna be fast and just for day-to-day use, just use the general mesh. But if you decided to do the polygonal approach, so what they do is they're gonna take some more time to calculate. First, the software is gonna create surface mesh, surface 2D surface mesh, and that 2D surface mesh will be generated or converted into 3D tetrahedral mesh later. So the good thing about the polygonal approach is that the mesh size, it will be constrained by the surface created. But sometimes you have to compare what is best for the data set, because it could be pro and con, because some small feature could be removed or could be restrained because of the polygonal approach on the surface created. We're gonna start with the direct approach and just use the features as it is. So you can protect bounding blocks or not. If you use not to protect bounding blocks, so you can just leave it done. But just use the protect feature the bounding. And you can see that by default they create this label image have 3 layers of the corn. So hard endosperm, soft endosperm, and germ. So by default, you can see at the bottom is the because we have direct approach is more kind of fast to generate. You can just select the mesh quality, and you can see that by default is medium quality. But if you just go to a bit lower or higher, you can see this preset have been created for you already. So I'll just start with the medium quality. You can see this for medium quality, you have the parameter of the facet size, the facet distance, cell size, and head size. Just click to create. Okay. I will repeat one more time just to be sure that everyone is still. Yeah. Yes. Yeah. So. Yeah, exactly. So right now I already create a mesh, and the mesh here appear on the mesh list. Sorry. You can see the mesh. We have the mesh.creator. So it's the file for exporting. And if you would like to export this, you can just select type of solver that you would like to. You can see that I have a list of Fluent, Abacus, and Sys, console, so on. This thing you can. Yeah, for example, you want to do finite element analysis or fluid dynamic computation, but I also have no experience on creating things, but people do the finite element analysis, so they need the matching, the match. Yeah, but this is one thing that you can use in Loga. Ronell, can you add up? You have any experience or something before? Yeah, exactly. So for example, you want to, I will show you later how can we create a few boundary condition and so on. Okay, I just go back quickly to repeat for everyone. What I did is just to open the data, and in this folder you can see the root. By default, you point to Avizo data folder and select tutorial folders, and in tutorial just select matching folder and just select this prepare data called label and open them. Once you open, you can just visualize in project workroom. And as you can see here, sometimes it happened that something going wrong with my preview like this. So you can go to Window, Restore Default Layout, so you get normal layout. And what I did is just to look at the data, volume, like this, or you can look at the auto slides here, clip them, or just use clipping page just to quickly understand the data set before you can proceed further. So you have 3 layers inside of the germ, and you have soft endosperm and hard endosperm of the 3 layers material. That's the prepared data. So if you have grayscale, first you need to do some multi-material fragmentation like multi-thresholding or iterative thresholding and anything like this, then you can come up with the label image. So now we have label image ready. Just go to matching workroom, select the matching tab. You enter to matching workroom. So the first thing we're gonna do, we're gonna create match. So just load the data. So we have only one data set open. It's kind of con.labels.am. And now we first try the direct approach. And with direct approach, I just use mesh quality of medium. And by default, you can see the parameter of the facet and cell size. And click to create. So when you can create, you can see the data set. It looks, yeah, you can see that actually it's not surface mesh anymore. So to see mesh from different material, you can see on this material over here. So you can click to, let's say, if I uncheck the hard endosperm material, you can see what it looks like the mesh for the soft endosperm and the germ. Or you can remove to see that only the mesh here. You can use the same 3D visualization here. You can use hand too. Zoom in, zoom out, use left click and with the mouse. Mostly people work on this analysis. They need, for example, if you click on S1, they have some parameter that you can to refine them to according to unit. I really don't have experience. So I'll just go slowly. So look at the different 3 materials. Yeah, you can see that. And for example, I can now try to change the quality. I go up to the low, right? And I can create or replace. So if you create, you're gonna generate the second paragraph mesh, but you just replace them to replace from this medium quality to low quality. So now I click replace. Or you can change to higher quality, a bit higher. Depends on your computer spec. So replace them, and then you can see it a bit more finer. So now I go back to the medium and I'll show you quickly on the 3D viewer. On the 3D viewer here, we have the spatial clipping for this mesh. So if you click on the clipping over here, click once, you can see that the clipping is spatial for the mesh in the machine workroom because it doesn't cut flat, it just clip to the tetrahedral mesh. So I show you this just to show you that this mesh is not 2D surface mesh, but it's 3D volume tetrahedral cell mesh. And you can change again the clipping direction, Y Z, Y Z, or you can just select to rotate the clipping. So after you activate the clipping, click rotate. When you click on the rotate, you can see this the location view coming up in the middle. To interact with this view, just change from hand to arrow to. Now you can okay, now with the visualization of the mesh. So now if I stop the clip and go back to XY plane, click one more time and rotate. So now change back to hand tool to interact with them. So quickly compare between the direct approach and polygonal approach. So you can see that direct approach is quite fast and just for day-to-day use. But if you would like to have it more quality control of the mesh, so you select polygonal approach because they're gonna create the surface mesh first and then convert the surface mesh. And you can see that you can use boundary layer and cell size. You can specify a bit more further, more refined fine-tuning of the parameters to create the mesh. So now we're gonna click create because I select the polygonal approach just to compare between the direct approach and polygonal approach. So click create. And now you can see that it's quite different. So on the top here, mesh panel, and if you click on the drop down menu, so you can see now I create two mesh. So the first one is from the polygonal, from the direct approach, and you can see from the polygonal approach. You can see the different. So the polygonal approach is more constrained, and some feature has been removed. For example, if you look here, zoom in. Then, yeah, because it is based on the surface. The surface first. Yeah. Yes. Yeah. Exactly. Exactly. So I will show you what it looks like in the surface. If you go back in the project view here, project view, and you can easily create the surface on the original data. This one, the headercon.labels.am. Right click and select generate surface. Generate surface. Okay. Right click and type on the search view, generate surface. And here you can see on the property port of the generate surface. So we have kind of some property that you can do. For example, you can select to have the compact surface, and here algorithm you can just select the repeatable. That's more correct. The way maybe also to answer because they have the fast approach and repeatable approach because the algorithm on the fast just to directly make it really easy to create it. But if you do repeatable, so they want to make sure that the surface that you created will be consistent from different, even from the different version. So if you use Avizo, the previous version or the next version with the repeatable, then the surface should be the same. And you can select smoothing. So you can, for example, show using the constraint smoothing or non-constraint. So just I select constraint because it's related to the machine that we create later. That's why you said why it's so smooth. Some feature, even the kind of intercalating feature will be removed. And here with the constraint smoothing, you can just select the smoothing extent, and again you can see you can change the max value. So let's say if you click on the three dots here, you can just change from maybe from 1 to 3 to 1 to 10. And you can just change maybe smoothing extent to 5. And then click apply to create a surface on the original label data. And now you get the surface file, and with this surface, right click, select to attach surface view to the surface, and create. Now you have this surface. And actually, if you look at this surface with clipping plane, so right click on the surface here, right click, and then clipping, and then I clip with the clipping function on the clipping plane property port. Clip. You can see the inside is a hollow surface. It's not a solid. So that's the difference. And now just to look further in this 2D surface on the surface view, at the property port of the surface, we click on the surface view here. At the property port, you can see that the draw style by default is shaded, but if you change to, let's say, first the outline, you can see this actually how the surface has been imposed with the triangle. So it's triangle the surface. Yeah. It just gives you the surface. For example, if you would like to export it as a surface for 3D printing, let's say here this surface. If you have maybe multi-component or even one component, and then you would like, if you have rock, for example, you can scan the rock with maybe several components that you want to. Yeah. 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 Exactly. This one you can also export the surface file. For example, you right click on this surface here, right click and to select export, and now you can see that you can export to different. No, but yeah, but if you want to do finite element analysis, you have to have the solid of the volume, and you can also set some boundary condition. But here it's just surface, and you can export them. For example, you want to export at STL and or wavefront OBJ. This is two most common that you're gonna do for 3D printing. Like Ronell, we have this scan coral, and you do segmentation of coral, and you finally generate the surface from the coral, and then you can send this for printing, and you can see there's some model of the 3D printing, so you can use this surface file at STL or wavefront for the printing. Yeah, for the simulation you have to store it. I just show you quickly what is the polygonal approach. For polygonal approach, it's just based on this surface generation, and this is surface. And yeah, do you know about this surface thickness thing? Yeah. Sure. Yeah. Mm-hmm. Yeah. So so no. Okay. Yeah. So yeah. So yeah. Yes, just to explain because you just say, yeah. So just forget about it. So I just, yeah, okay, yeah. So now you know what is the 2D surface mesh compared to the 3D surface mesh. So 3D tetrahedral mesh. So now we have these two mesh that you can use for export, and yeah, just want to explain between different direct and polygonal approach. You can see the first one is direct approach. What you see here, that because direct approach, they generate directly from the data. Sometimes you have these thin structures being protected or being preserved. But if you just use the polygonal, some of them has been removed because they kind of constrain smoothing. But something you can see here. So it's hard to judge. It depends on what your application. Maybe you need to have direct approach or polygonal approach. So for example, if I go back to the first direct approach, and you can also, let's say, create the different mesh quality in a different layer. So if I add a group here, and I select the hard endosperm into this group by drag into the group, and then now I just uncheck the germ and the soft endosperm. So I have only this group of a hard endosperm pane here. So I will just make mesh quality to high, and then you can click replace. Yeah, so now I have the more really finer 3D image of the hard endosperm, and then I come back with the original top in germ. You can see that you can. Yeah, we have this. That's just a boundary condition. What you mean, right? So if you would like to see the boundary, for example, you can see that we are having a tab here that you can select. For example, I show you the contact between the data. So you can see both sides they have the you have to select what is the boundary you're looking at. So by uncheck here, so you see only the material you select. So if I select only the germ, I see the germ. And now to create the contact space or boundary between the two materials, you can just select by click on one of each data. For example, I want to see the contact between soft endosperm and the germ, and you can see the red contact space has been created. Or if I want to see the contact space between hard endosperm and the soft endosperm, or the hard endosperm with the germ. So the tick is just to visualize the mesh. If I tick to visualize the mesh here, mark. So this is a tick of the to visualize them. And the highlight is just where you want to see the boundary condition, the border between the germ and the hard endosperm, germ and soft endosperm. It's set here with the visualization here. Yeah. For example, if I just visualize first the tick on the hard endosperm and look at the boundary condition, the contact space between the germ and the soft endosperm and the hard endosperm. So I have several contact boundary conditions. And yeah, okay. So what I want to do now, we're gonna export this boundary condition together with the mesh. So you just have to decide which boundary condition you actually want to export. So maybe I want to export this boundary condition. And to do that, I just need to select the name. So I say, let's say I add this is the interface between germ and so on, and then you can just select the axis, add. So you can add this as interface. So you can see type and click add. Here boundary condition is the same name. Okay, this first. So I do another interface, and now okay, I just because I want to make an interface, so I just select interface and click add and add. So now you can see these interfaces are embedded in this mesh. You can export together with your mesh. So this is contact between the two boundary, the boundary condition. And when you go back to meshing, to click export here, you can just select any solver file like console, and then you click export. Any question on this? Just simple how to generate using this workroom parameter. Again, if you have any question on this workroom, you can click on the question mark. Then we load the menu, so they're gonna have this explanation of the matching, and you can also even look at the tutorial as well. So matching workroom, and we have so-called a tutorial to explain different approach, how you can create different type of mesh, and even set some boundaries that you can see that different layer of the mesh quality in the same material. So the reason that we have, what I showed before, that you create some boundary condition and export together with the data. The reason we have this meshing because it's more visual and you can easily look at the data set before you proceed further. But then we also have more fine-tuned parameter to create on the project workroom as well. So I remove everything quickly. And you load the same data set. So easily you can go to start. You can already see that the same file has been created here. I mean, it's open before the kind of font label, so you don't have to click open on the spot. You just technically select and open it. Okay. So now, if you would like to, if you know a lot of the, to adjust the parameter of the meshing already, so you can right click and select generate data mesh. So this is similar to what we did before in the meshing module, but this is just the module. This thing gives you much more control on the meshing. So you can see here, you can select the advanced mode. And then with advanced, so you can even further define the meshing to be created. As you can see, a lot of parameters to be optimized. Like here, you can see this draw iteration, ODT iteration, retrieval angle. So I have no idea. Some people who can use this, so will be even using the meshing, and it already exists in Avizo. Yeah, is it fine so far with the meshing? Just to give you an overview. So the next thing we're gonna do is to look at the most important one, Pore network modeling. To see the connectivity, the Pore. So just to remove this, I press Control N. Everything is easy. Control N. If they ask you to save, you can just discard. So now we're gonna jump into the new tutorial for Pore network modeling. Hi, good morning. So for it, we need to open the data that are related to Pore network modeling. So go back to the data folder. And in data, when you click open, just select data folders and then go to the tutorial folders. And in tutorial, just select ENM folder. So Pore network model, ENM. And here we also have some prepared data and some tutorial, but just select to open the Wansaram, the data. Wansaram, it's a form data. Okay. Click open. Again, the voxel size has been set to 0.11 nanometer. Okay. And here you can press this view all. Now attach, right click, attach volume rendering, right click and select volume rendering to attach this data. Now you can see this actually is a form data set with the porosity or cheese, but actually it's form. So you can set dynamic range of color map. So you in the volume rendering module on the bottom tab, just adjust dynamic range of color map, or you can just easily click on the edit, just range to data histogram. Get this kind of, but data histogram is not very well. Just do data window. But you can adjust further to make it more solid or more transparent. So the idea here, what we're gonna do with Pore network modeling, we need to first extract the pore space, and we're gonna see the connectivity between this pore. We're gonna see the flow, the connectivity. Yes. Yeah. You want to explain like yesterday we talking about? Yeah, definitely. So at this point, everyone okay with loading the data set? Yeah. Yeah. So the first thing we're gonna do, we need to segment the pore. Yeah. We can easily using threshold tool. So it could be anything. You can use automatic thresholding like we did yesterday. You can do interactive thresholding, multi-thresholding. Just select the certain value. For this, I can give you the easiest one. Just do auto thresholding. Okay, right click and type auto thresholding. With auto thresholding here, this module attached to the data. When you click on the auto thresholding, it appears on the property port that we have type. So you can see that I have three types. So auto threshold high, auto threshold low, and auto segment three phases. Again, if you click on the sponsor dataset itself, you can see the property of this dataset, and you can see the histogram of the intensity. So we have like two peaks, so that means you have to select high value threshold or low value threshold, and here it's easy to see that our pore space is on a low value. So we're gonna select auto threshold low. Okay. Because if you look on the auto slide, maybe easier. Yes, you can see this the pore space is on the black intensity value. You can see the pixel on the black. So this is a pore, and they have like low intensity. So by default, you can see the curve here. It have two peaks. Maybe easier. You can see the histogram over here of the intensity distribution. So they have in the lower range and the higher range. So this module auto thresholding just automatically detect the pixel that have intensity in a higher range or in a lower range. So you can just select. If you select auto threshold low, you just threshold or create mask over this only the darker pixels. But if you select auto threshold high, you can also create the bright material. But you can do both. I can also give you alternative as well. So if I quickly select auto threshold low and click apply, then you always get info file, delete it if you don't need it. Yeah. Yeah. Mm-hmm. Yeah. Sure. I know it's useful, but I don't want to make too much string because people get like yeah. Yeah. Mm-hmm. Yeah. And here, because I use auto slide just to visualize the result. So in auto slide of the original data, grayscale font slam, you can right click on the auto slide, and you can see on the second on the list is color watch. Click on color watch and create or double click. Yeah. So initial dataset attach auto slice, and auto slide on the module, right click and attach color watch. Okay. So the color watch should attach on the bottom of the auto slice. And in color watch, you can select to attach color watch to the data. You can see this on the data part of color watch. You can select which data to attach to. You can see you can attach to the same dataset, but it doesn't make sense. So you're gonna attach to the new, the label. So what we do here, we want to overlay the segmented result to the data. So this is auto threshold low. Again, in color watch, you can change the transparency of overlay. And you can change color map as well from 8 colors to 256 colors. As you like. It's just automatic. So it might not be precise, but if you want to be precise, maybe you can do interactive thresholding. Okay. So if by mistake you don't do auto threshold low, you can do auto threshold high like this and click apply. And now you can see that it threshold on a high intensity pixel value. If you do auto threshold high, then you can invert them to get the void space. Should be 2 or maximum 3 if you do a multi-threshold or 3 phases, so you can have 3 materials. Yeah, I mean include background as well, so it's gonna be 2 materials. Yeah. So if I just invert them, and then you can pull the string of color watch to see here. You get 4 space. So different approaches, but not gonna confuse you. So I'll just use auto threshold low just to get threshold and remove this step. So now I use auto threshold low to extract the pore space, look like this. And the next step that we're gonna do is kind of create the connectivity. So we're gonna select only the pore that are connected to each other. We will remove the non-connected pore. Yeah. Mm-hmm. Mm-hmm. Yeah. No, because of the you see like this. Because in the overlay, you mean yes. Just overlay that you put overlay data on top of each other. Yeah, like here is original data, and I want to overlay the label just to see how your segment coming up. So, yeah, yeah, exactly. Just to see visualize the data. So this original grayscale data, and when you overlay on the label image, so you can see how the segment coming up, because you want to see here sometimes like is it precise or is anything. Yeah, you can see that they kind of approximate because some certain is of cover, but anyway, it's the approximation of the segmentation. And as you can see that there are some pores are not connected to each other, so we're going to remove this because we want to see only the connected pore, the connectivity between the pore, the void space. So to do that, we need to attach right click axis connectivity. So now it depends on how much we would like to look at the maximum or minimum neighbor connectivity. So I just select the maximum neighborhood of 26, and we're gonna look at the connectivity on the flat axis. So just use this before 26. Now I get the result from axis connectivity, but if you look at the thumbnail, you can already see that some of the pore has been removed. Or you can do the same thing with color watch. So if you pull strings from the label image to the axis connectivity result, you can see some of the pore has been removed. Just look at only, we include only the connected pore. And maybe in 2D, it doesn't represent everything. We have to look also in 3D just to compare. Like here, before we do the exit connectivity, we have some, yes, object connected. Mm-hmm. I am not certain. Yeah. That's true. Yeah, you're right. Mm-hmm. Okay. Yeah. Maybe you need to do adjust the transparency. Yeah. But as you can see, when you exit connectivity, the clearly. Sorry. But you use the same version? Yeah, because it's in 2D, but in 3D it might be connected because you have to interpret in 3D because even it looks isolated at this slide, but it go later that might connect it later. That's why I showed the volume rendering because sometimes in 2D it looks isolated, but in 3D probably already connected. Yeah, sure. Yeah.
Rolf, do you have these? When you create access connectivity, does it show you something?
Yeah, I think you have the low-end graphic card. You have the Intel graphic card, that's why. Yeah, because usually the laptop they have
No,
to
it's not
integrate the
laptop,
graphics.
it's PC.
You have NVIDIA graphic card because I think this is not supported because they need the some kind of we usually yeah yeah because we need some like OpenGL and then I think this is really outdated.
She has the
yeah, you can go to the NVIDIA control panel.
Can we save?
Save as minimize project mutation. Minimize project mutation, but you can need to recap.
Please don't
I guess. Yeah, and okay. Yeah. So somewhere like that. Yeah. Yeah. And go to the second one or the first one and select the second one. Yeah, yeah, and select. Oh, then go to the first one, the global setting. OpenGL.
Need to push the program.
Avizo.
You want to make global for everyone?
And also go back to the global setting as well and select the OpenGL's landing view. Okay,
Wait.
and NVIDIA.
You mean
Yeah.
all?
Yeah.
During time?
Yeah. Apply.
Just allow video to record in.
Yeah, to use the right NVIDIA. Check.
By default, the program for some reason is
system information.
you need to stay.
No problem. Yeah. So now you need to make sure that it's call for open NVIDIA graphic card. about ThermoFisher.
I need to specify
Yeah.
exact file.
So, any questions so far? Check on the screen here what they, because it's doesn't detect the GPU from the NVIDIA. So they use the Intel graphic card. Let's try to set the NVIDIA graphic card to. They have it, but this is not that point directly. Yeah, yeah, yeah. Or you can sit with someone that have the computer. So after exit connectivity, you can see that there are some pore has been removed based on this criteria that we want to have already connected, and that's why I show you on the 3D as well. That show you that even it look in 2D they are not connected, but in 3D actually most of the non-connected have been removed. So you at this step, step, you can also look at the volume fraction. So I turn off here quickly. So if you would like to select the volume, calculate the volume fraction of this connected pore into entire volume, what you could do, you can do create the full block. So go to the original grayscale data. Yes. Yeah. Yeah. So I use the set axis. Yeah. Mm-hmm. Yeah. Thank you. So now I'm gonna create the so-called interactive pressuring. So right click on the original grayscale data, interactive pressuring. With interactive pressuring, I just look at the 2D. Now so I can adjust the intensity range from 0 to maximum. Yes, so I can have everything. Or it depends on what you define. So if I have everything like this and I get it locked, and now I'm gonna calculate the volume fraction of this connected pore here. So what I want to show you is that here, maybe change color of this to 56. Yeah. So I want to see how much percentage of the connected pore inside the full volume. So you can calculate by yeah, you can do anything you like. For example, I do this just to create the solid volume block. Total volume. Yeah, yeah. So I creating, and now I want to see how much of volume that I have as a volume fraction. To do that, I just need to select the result from axis connectivity and select volume fraction. Just simple calculation. In volume fraction, you need to input the mass. This is why I create the. You need a mass. That is. You sure? You need a mass. You still need a mass. So Then I add the mask, which is this one. I just create the full volume. Input image mask. Yeah, it's a level. But you need to in reference to the to the full volume and how much of the percentage of the fraction of the connected. So now I apply. Yeah. So now I get to see that volume fraction is 51% of the connected pore. That's okay. I can maybe visualize them quickly to show you as well if I have again this volume rendering. Now I have this range behavior. I do something with 3D. Yes. There we go. That's great. Yeah, I think it's something I don't even activate it. Yeah, I don't even create a stereo. Something else. Pore. I think the same thing. Okay. Yeah, it's been reset. So go to NVIDIA control panel. Yeah. Okay. So what I usually do with the NVIDIA control panel, use the advanced 3D image setting. Okay. On the adjust image setting with the first tab, just use advanced 3D image setting. And then for the manage 3D setting, so usually they call auto select. We're gonna use high performance immediate processor. Okay, you have this setting. Okay. Yeah. Yeah. Okay, I just do it. I already adjusted, so for me it's fine.
Because I found the option for in Windows, not in NVIDIA control panel, but in Windows.
Okay.
How to specify
Program to use the
yes,
NVIDIA.
yes.
Okay.
For example, I don't know, that program. Okay. In the settings.
Yeah. Okay. Then that should be okay now with. Yeah. Yeah. I don't know why it just switched immediately before it's completed. Yeah, now it's come back to NVIDIA. Okay, I just repeat. Okay, just to follow. Okay, first open sponsoram.am and here use auto thresholding. And use auto threshold low. Apply. And the result they will make. Gonna use axis connectivity in set direction with maximum number of neighborhood 26. Apply. And from here I was briefly to see volume fraction of the connected pore by thresholding with 0 to maximum intensity. So cover, click apply. So this is the mask. So maybe you can rename them. Rename as mask. So now I want to create volume fraction. Right click, volume fraction. And with volume fraction, you have to specify the input mask or click here, input image mask, so this mask, and then click apply, and then you get the table of the volume fraction 51%. Yeah, I just use everything from 0 to maximum because you see that intensity is only in this curve range, so you have to make sure it just starts from everything from 0 to maximum. So it's just a volume fraction. Leave it aside. So now we continue with the connectivity. So the result from this connectivity here, the next thing we're gonna do, I turn off interactive thresholding as well, not to get confused. So step over here and here. Okay, from the result from connectivity, we're gonna do separate object. So right click, select separate object, and let's say do the market extent of 2 with output type connected object. Okay, separate object, market extent 2, and output type connected object. So in the rest, just use the default parameters, so 3D interpretation and some number of neighborhoods. No, we're gonna label them. Yeah, because so far, if you look at the this step on volume rendering, see that it's still one material. You want to separate them and have individual pore space. Okay, click apply, and here you can see that they become individual pore. So if every color have their own ID, so you can see, okay, pore number 1, 2, 3. Just don't focus on how it's separated. Result we already discussed this thing. Okay, now we ready. We prepare the data to run the Pore network model. Yes. Yeah, but not yet. We don't need to do the calculation yet. We need to see individual of the pore, and then later we're gonna see how they connected. Yeah. I don't hear you. Sorry. Separate objects. So because it's just criteria how you would like to separate. So I just try to use the lower market extent to have more objects separate as much as possible. And I just interpret them as 3D because we look at the 3D pore space. And this connected object option is just to label them, because if you don't use connected object, you use the split, you can see that it looks just like this, and then you have to label them later. But it's just easier to select the connected object option, so they will be labeling. But the color is just randomly assigned. Okay. And at this step, we really prepare the data to calculate or to generate the pore space or network for connectivity. So right click on this separate result option and then select generate pore network model. Generate. So many. Yeah, but it's a different one. For yeah, generate pore network model. Separate as individual object, because if you don't it's more, maybe the separation is the wrong term, but just to see that they have individual ID. Otherwise, they're gonna consider as one group of objects. You will see. Yes, you will see after this. So we're gonna attach the module called generate pore network model. Be sure to use generate pore network model, not pore based ENM generation, because that's one for the binary image. Okay, generate pore network model. And this module you can select to generate property as well. When you select to generate the properties, then you can input the direction, step, and I just use for battery values, input pressure, output pressure, and fluid viscosity. Okay. Just to simulate, like to see how the flow inside of this pore, yeah, because you're going to see the, for example, flow rate inside of this calculation of the pore, because later we're going to simulate the so-called throat, and then you will see the property. So this is the option that you can generate property or not. If you don't select to generate property, you will not see the flow rate per second, for example. So you want to see like how much of the flow rate per second into this pore is based on the channel length, throat diameter, but how you will see, just click apply, yeah, and after that you will get, so they have some warning because you said some of the throat smaller than the voxel. So this is also the issue, because sometimes when you scan the porosity is too small than the voxel size, then the calculation might not correct that throat. So now you get two of the results. So you get the properties, and if you look at the property, it's like this. Yeah. So you can see the decay and the flow rate per second, viscosity. The information, just the property that we created. But if you don't select it, you're not gonna have this property. For the pore, the result is called sponsoram PNM dot flooded. This is the pore model. So I will just remove volume rendering quickly, so not to confuse, just delete quickly. So now just focus on the PNM flooded. Okay. To visualize them, right click on the PNM dot flooded and attach pore network model view. Great. So they come up with the pore network, and now we need to specify two things. We have the pore and the throat. Okay, for the pore, you can see that we have pore scale now it's constant, or just leave it constant for a while, and then you can increase the pore factor, scale factor. The same for the throat. You can change the scale factor. Okay. For the time being, I showed this the connectivity between the pore and the throat, the channel. Why? Because if you look at the result here, the sponsoram not flooded, you can click to show the table. So, and in the table, you have two sections, pore and throat. And go back here to see quickly. And in the, let's say by default pore, if you just select on one of each, they just highlight where is the pore property. So you have volume, area, equivalent radius, and some kind of pressure and flow rate per second later. And you can select even a few of them, click chip, and you can just select where it's highlighted. Where the same for the throat. If you click on a tab below here, tab throat, and you can just select which throat that you are seeing. And you can do the same, select several of the throat, try to see property. Yes. Because I just want to show you the visualize, but later I will show you the color based on different properties. As you can see here in the throat, we have property like area, equivalent radius, channel length. You will see. Exactly. Yeah. You will see. Just give me 1 minute just to explain the table and what is flow rate per second. You can see all the properties here. And now I go back to the pore network model view quickly. The property, the windows here, the pore network model view. And now I'm gonna colorize them. Yeah, exactly. Thank you. So for the pore scale now, I gonna change to equivalent radius, and the color as well, go to equivalent radius. And now I'm gonna increase the scale, and then you can see that the color start to come up based on the size of the pore as equivalent radius. And now if I overlay on top of original data with volume rendering, so attach volume rendering to original data, you can see something like this. So this is represent each ball represent equivalent radius of the pore space, and the throat also represent the connectivity between this pore. And if I go back again to the pore network model view, for the same, for the throat here, instead of constant, I'm gonna go to channel length, for example, and you can see that the channel length is proportional to the size of the throat. The color again, you can also change to channel length or flow rate per second. And this flow rate per second parameter is being calculated based on the property that I generated over here on the product model. And you can also change color map of the channel length. Is it okay at this point? Any further question or comment, or if you still not clear? Because when you overlay on top of the volume rendering, it's kind of clearer, right? Because first we need to segment the pore using auto thresholding, auto threshold load, so all this pore space has been segmented, and then we just select only the pore that are somehow connected, and then we separate them into individual pore because we want to calculate the pore network connectivity. And at this point, we can look at the equivalent radius or equivalent volume of the pore as a sphere, and then calculate the, for example, flow rate or the channel length like this. So if you consider the throat at the length and the channel that connects between the two spaces. Is it okay so far at this point? Sorry, I cannot hear you. Hello, Pat. So you go to this pore network model, and column map should be on somewhere. Sorry, I have to look here. Usually it could be possible to show the column map. Yeah. Where is it? Ah, yeah. Exactly, but they have to be on this. Oh, yeah. Sorry. I don't know why it doesn't come up at the first time, because I tried to do the column map region. It doesn't. Okay. Anyway, so you have to create column map legend attached to the pore network model view, then they come up with the legend. And in column map legend, I think you can also adjust column map. Oh yeah. So I select, for example, based the color. You see the pore coloring. Here, right click, and then you could type color map legend. It should come up. I try one more time because it seems to screen. Color map screen. Okay. So what we did before is more like this. We right click in the empty space somewhere. Right click, empty space, and select create object. And then you can type color map from search box. When the color map come up, and yeah, as the Ronell suggested, it's color map legend. As it might be a bit of bug as well, and then I attach the color map to this point, because usually it should be able to directly search for color map on this kind of point. I'm not sure is it a bug because we never, yeah, when we do have the new beta version, usually we did test on the extension because we don't use it extensively. But yeah, it's good to realize. Okay, then that's good to know. Yeah, thank you. Yeah, I will do it definitely. Yeah, but usually it should be automatically. Yeah, sure. It's not done, but at this step we can take a break. Yeah, we have some few steps more. So from here we're gonna create, for example, distribution analysis. As you can see here, if I look on the table of this consoram.pnm that was flooded. So if you look at the pore, we have this property of the pore: volume, area, equivalent diameter, radius, sorry, and then so on. For example, if you would like to look at distribution of equivalent radius and against the volume. So we're gonna do by right-click on this result from generated Pore network model. Right-click and select distribution analysis. And in the distribution analysis module, the property here, you have to select the property in X and Y. With X, I'm gonna use equivalent radius, and the property in Y can select volume. Okay, and then just use the detected automatic range because they use the maximum, minimum, maximum from 0.04 to maximum 0.55, and number of bits is 50, and click apply. So now we get the distribution. So what you could do here, you can do a plot spreadsheet. So right click on the result from the distribution analysis. Right click and then select plot spreadsheet. In plot spreadsheet, just to select the X as the table 1 equivalent radius, and the Y, just select table 1 sum volume, and then click show on the plot for here. So we have the plot. You can also select to show the marker line as well, which has been plot. Okay. Yes. Which step? Yes, distribution analysis. So with distribution analysis, you just need to the what? The range is automatically detected. As you can see from here, the legend, you can see that the select the minimum, because from the table they already detect what is the minimum and the minimum. For example, if you look at the Pore volume, you can start extending, descending, and then you just detect the minimum range, the maximum range. Or you can define anything from 0 to, but you can see the value here, it starts from the smallest value and then maximum value. So if you look at the equivalent radius, the maximum is 5515, and you saw them ascending or descending, and you can see the lower range and the maximum range. What do you mean? I don't understand this. Okay. Maybe we can do a different approach. Maybe number of bins. Maybe from the calculation. Yeah, it doesn't matter because the number is just automatically taken. It depends on the column do not have the same size. That's really strange. Okay. 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 I have no idea. So yeah. Random bug. Hopefully. Yeah. So instead of plotting the spreadsheet, you can also do correlation with the module. So if you would like to visualize them in the histogram, you can go to Window and select correlation. So now the new tab of correlation appear, and then in the x-axis you just have to select this the distribution. So you scroll down, you can see that the result is this one that we just calculate from the distribution analysis. So just select the distribution, consortium PLM distribution, and for the x, you're gonna do the equivalent radius, and for the y-axis again distribution, and select some volume, and then click this add here to add your calculation. And now you get the same plot, but now you can select, for example, you want to do the log values, and then select marker like histogram, or you want to change to marker. So this is just to visualize the correlation, and you can apply to any calculation. It doesn't have to be only just model. For example, you have the distribution analysis of the particle or porosity, so you can just use this distribution, and you can just select the property that you want to plot in x and y. Yeah. Any question at this point? You want to have any something else to add? So after this, we can do another thing is that you can do some filter. So you can type on the Pore network model, the flatted one, right click and select Pore network model filter on the compute folder, Pore network model filter. And when you attach the module Pore network model filter, what you can do here, I'm gonna select the element is Pore and Throat, but maybe we work with the Pore. With the Pore, I want to filter them based on the volume or area equivalent radius, but just select the volume. Double click on this volume, you can see here, double click on it. And then when you double click, the expression appear on the filter. Okay. So then you need to define your values. For example, I look on the table one more time. You can see this is the volume that we look at, and you can see that you can sort ascending and descending. You can see this column over here that I sort on the volume. So if you want to select only the larger pore and exclude some of smaller pore, then you can go back to here, and then let's say I want this larger than certain values. I cannot find the one. No. How can I use the modern side? It's a bit different keyboard. Thank you. So that's what I want to use the equation. For example, I want to have the volume that's larger. For example, if I do this sorting, you can see that I have the smallest from this value, and then I want at certain point something at halfway. So let's say I want volume more than 0.02. Okay. And you can see when you do this expression, when it's not complete, it's still red because you need to complete the expression. It's mathematical operation. So when I add volume more than, it's still red, but then if you put some value like 0.02 of the volume, click apply. Now you get the new Pore network model. You can use the same Pore network model view to view the new pore. You can see that it's been filtered based on the size. The smaller size pore has been removed, and only the larger pore that's larger than this one. So As you can see, I just filter them based on the pore size that are larger than this value, because you can see here the distribution of the pore size. Okay. You can also look at the pore intersection as well. Go to original the data again, from generate pore network model, and select pore intersection. Pore intersection. Okay. With pore intersection, we need to input binary image. So the binary image is go back on the step the result from separate object. This is the binary that we're going to input for pore intersection. So remember, if you go up and we do this object option, step the result from separate object, we're going to use this as the input in this pore intersection. So for intersection, select binary image of the separate. Oh, sorry, I'm not separate. So we this one, and then just apply. So you get the intersection, and click show intersection. Original one and the intersection. Yeah, that's pretty much of the pore network model. So you can play around with some parameters to see distribution analysis to filter them based on size and to plot the property, calculate volume fraction, and so on. Any question at this point? So then we can. Yes. Yes, exactly. So it's based on the filter again, because you filter first and then you see what is this filter connected to what we have in the previous one before the filter. Yeah, maybe a quick thing to save the project. You can go to File, Save Project As, and usually when you save, you will have two options to minimize the project size. That means you can save as small volume data, but I would not recommend it. Just try to minimize the project computation, because if you do a lot of calculation next time when you load the data, it should be saved immediately. But if you're not, it's gonna take some time to recalculate again. Click OK, and then another option is that you can select to save just the project and you have the file embedded in your local computer. But if you would like to transfer this project or move to somewhere else, make sure to save as pack and go, because this is embedded data file. So for example, if you work on this computer and you want to move to another computer, if you save with pack and go, you can be sure that you are embedded the data. Otherwise, if you move to another computer, you cannot find the original data. It's going to be a problem. Always like this. Yeah. Yeah. Like instead of looking for the local computer where the original file, you just save as pack and go, so you can directly. Yeah. For example, you want to send it to me, or just, yeah, you don't have to send separate data. You just save as pack and go. That's how to save the data. And since we are here, maybe we can show you quickly. I already mentioned it, but maybe it's good to mention it again. You can also save this as a viewer. For example, you would like to present this on the conference, and you cannot access to Avizo, or you don't have Avizo installed on your computer. So you can save as to go. So go to File and Export Project as to go. This is a to go story viewer. You cannot do any calculation or any modification just to view them, but export as to go. And I will save. Can I save somewhere? Desktop. Yeah, save on desktop, and then to go, and then save. And then you can select, for example, your name and your organization, like this. And you can select to export anything, the graph, the table, and okay. Then now you get the Google file. I'm not sure if you have to go here, but then let's say Yeah, I'll show you later. Then later you can go to the website on ThermoFisher and download Avizo to go, and you can just gonna view everything. Like as you can see here, you can show like directly on your computer, even without the Avizo license. You can just see all the table, you see the workflow, you see the volume, really everything like you see on Avizo. Yeah. 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 Really. So yeah. Yeah, so to go viewer, and then for example, if I download, it's gonna take quickly, and then when it's done, I'll just show you quickly later. Okay, now yeah, yeah, yeah. So one is done, I will show you how it looks like in Avizo to go. Now I come back to Avizo, and we're gonna start now with the simulation. So you can press, after you save it, you can press Control N. And if you don't save, they can ask you if you want to remove all this project. But yeah, remove it. For the Pore network model, not yet. We gonna start. Yeah, yes. Yeah, sure. Yeah. Yeah, sure. It's not much on the Pore network. It's the similar. It's similar to previous step because it's gonna have the same exit connectivity. Okay. So for the simulation, we need to load the right data, open data. Oh yeah. Before generate the simulation, first we need to work on the unit because it's quite important. Go to Edit, Preferences, and make sure that the unit tab. Here we're gonna work on micrometers. So change the unit to micrometers. Okay. Edit Preferences, and then select the unit tab over here, and then change the working unit to micrometer. Okay. Because it's the data set is in micrometer. Otherwise, you're gonna mess up with the unit that we want to work. Yeah. So if you change it, then we will have to remove all the data because it's been reset. And then when you change the working unit in Edit Preferences, you have also to change here as well. You have the corresponding micrometer unit that you're gonna work with. Okay. And now it's ready. That's the requirement. So open data again. Now it should be on program file, and go to Avizo 2020, whatever version you have, it doesn't matter. See the same data. And then data folder and tutorials, and it's on the XLab. So this is the name of extension, so XLab. So I don't know why it's for XLab, but it's simulation. And then we have this data set of bits. So just select the first one, the 200.0, and open. So we need to work a bit on this data set. So the first thing we gonna add median filter. So right click. Sure. Yeah. Mm-hmm. Yeah. 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 I think it's Yeah, it should be on the acquisition. Okay. Mm-hmm. Mm-hmm. Interesting. Yeah, so it's on the XLab data tutorials and XLab and first dataset 10MC3 200.4. Yeah, but make sure now that before you open the data, you change the unit first to the micrometers. As you can see here, we need to make sure that everything is on the micrometers unit, and the box size has to be 3.8, 3.8. It has to be isometric, uniform voxel size. As I mentioned already, if you import your data and it's not uniform voxel size, you have to change them. Situate uniform in ISO scale or XY. So in this case, it's 3.8 voxel size. Yes. So we're gonna do absolute permeability in the Z direction to this pore space. Yeah. Okay, let's say at pore. So the dark thing it will be pore because this is the white thing in the bead. Yeah. Now we're gonna segment the pore. Before segment that we can create quickly median filter. So right click and type median filter example. Not yet. So I'm not sure because it seems to me it's not that filter. You can see still some artifact, ring artifact. And it's too big anyway to calculate the full volume. You see later, I'm gonna select only the region of interest to work with. So just quick, just to give you an overview that if you apply some filter to easier to manage the thresholding step. So after median filter, you can see the bit at the boundary of bead contact. You think so? Yeah. So it depends on the data set. So if you think it's too bad, and you can just skip the step. So I just want to like something in general. And now we're gonna segment pore by using threshold. So this is one interactive thresholding. Interactive thresholding. So right click and type interactive thresholding. Should get this interactive thresholding coming up. Because you can really define your threshold value because auto thresholding is automatically based on the histogram. You cannot change the value, but interactive thresholding you can easily adjust the threshold intensity range. Yeah. So if you want to see interactive thresholding, you can just remove auto slide by delete them. You can see now by default they try to like you can see this is automatic detection on the interactive thresholding is like auto thresholding, but you can then start to define the range on the scale here. So I'm gonna use intensity from 0 here, 0 up to 114 like this. So this is my pore space. Yeah, because if you use auto threshold low, they probably maybe detect something a bit. It depends on. So you can define better on the thresholding. You can do more. I will just do just at 114. Okay, so you can see this is my pore space. Okay, then click apply. Now I get to see the result of the pore space in blue. But if you turn off the visibility of the interactive thresholding module, you can directly visualize them with auto slide of this data. The previous is similar to PNM step. Again, if you would like to visualize them using original data, overlay with color watch, again right click, color watch, and data. Yeah. So the next step is the same with PNM, that we need to do the axis connectivity. So right click, attach axis connectivity. with axis connectivity, so we have also axis propagation, but just do axis connectivity. And this time I'm gonna use the minimum number of neighborhoods, so to 6, because you want to see in one direction, not just to go to. Maybe you can explain further about this. We want to limit the property of the simulation, the flow direction, not just on one axis, not just to. Yeah, yeah. But if you look on the cube, if you look, you only consider the not direction, the connectivity between the face of the cube. Like if you have voxel as a cube, 6 faces that you consider them that's the minimum neighborhood. But if you consider the maximum, that means even on the edge and the apices, even you have the voxel that have edge contact, they consider this also a contacting point. So it depends on you if you want to have the minimum, but it's like recommended for simulation just to use the maximum contact on face. Mm-hmm. 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 Yeah. Mm-hmm. Mm-hmm. Yeah. Yeah. Yeah, so I think the reason is that if you consider this as a cube and you only consider the contact face to face, we're not gonna consider this only the edge contact, and we not consider the point, the apices contact. So that's why it's a minimum. But if you increase to 18, that means you also consider the edge of the corner edge, and then maximum is even on the small apices edge. Mm-hmm. Yeah. Mm-hmm. Okay. Yeah, and also just to minimize the computation because it's heavy computation as well. Mm-hmm. Yeah, yeah. Thank you for the comment. So now just click apply to calculate the connectivity. Okay. So yeah, as you can see here, what I'm gonna do right now, we need to define the region to work with, because as I told you before, to calculate everything in full volume is too big. So we need to define the region of interest. So I'm gonna attach the region of interest. So you can type right box, outright box. Yeah. But here we're gonna simulate the flow. The Yeah, the engine is too big to run on the larger volume, so that's why we limited just to show them. But you can run on larger volume, but to like tutorial thing. I don't want to spend too much time on calculating. Yeah. What do you mean method? The absolute probability. Method. I'm not sure what do you mean method. It's, yeah, it's kind of module that come up directly. So we have the different simulation. Yeah. So first I'm gonna select the right box, and here because it's on the perspective view, I can go quickly to the orthographic view. So this way I can see clearly. So I'm gonna extract only the center part of the volume to be working with. So I use the value of, let's say, have to be the same size on all direction to 85, and let's say I know this value because I use it before, 473. So you can kind of extract only center or top volume. Okay. Yeah. Smart starter. Mhm. Yeah. Mm-hmm. Yeah. Yeah. And now I'm gonna attach this module called absolute probability experimental. Yeah, this one you can see that on the second one, absolute probability experiment simulation is on the XLab. So you can have different type of absolute probability. Yeah, even the lattice Bowman. But okay, we're gonna work on the absolute probability experiment simulation. Okay, you just type absolute and you can select this one, absolute probability experiment simulation. And you can see on the property port of this absolute probability experiment simulation, you can select the ROI, the region of interest. So just select the ROI box. And then see it connected to the region that we're gonna work only this region only. And the next thing is you need to select the pore space. As you can see, because I threshold the pore space already, then this our material should be 1, not 0. So 0 is the background and the 1 is the segmented data. So you have to select accordingly what is your data set. So if you didn't segment the pore, if you just segment the bit, and then the pore will be 0 as a background. But if you segment the pore directly like this, so the pore is white open because it's blue. And yeah, so everything else I just use this so default parameter as well. Okay, and then click apply. Okay, let's try. I'm not sure because you see the RTX. Okay, that's good. Yeah. And then you will get, oh, it's very fast. That's why this is fast. Because, you know. So you get the error spreadsheet, and you can see that you can do this spreadsheet and take a look at information. Yeah. Okay. You have this component of pressure and velocity. Now I'm gonna work on the velocity. We want to see the velocity and to simulate this velocity. First thing, we need to compute the magnitude of the velocity. So right click on this component, the velocity tab here, right click and select magnitude. So it's on the compute folder, so it's magnitude. And with magnitude, you can see that nothing much you can do, just click apply and you get the magnitude file. So now I'm gonna visualize the velocity using the illuminate streamline. So right click on the velocity tab and type illuminated streamline. It's a display, so to visualize the display. And in illuminated streamline, you can connect the color field to the magnitude. So click on this little white box here, the first one. You see the color field. With color field, you can get the string and attach string to the magnitude, the result from the magnitude. Okay. So I will turn off color auto slide quickly, or you can delete it completely. Now come back to illuminate streamline. So now you can change like a number of lines to be stimulate 500, 250 or anything. And now we can start to do the animate and then click apply. So this so then you can, let's say, change color map at the bottom of the illuminated streamline to physics. Okay, edit and select physics color map. That's the number color map properties. And now you can change speed and all the stuff. For example, length of the width, fade factor, and step size. And you can also try different option in visualization. Let's say if you try this DAC option. Because I use the right box here, remember? This is the one that I just limit the calculation only. Because when we calculate this exit connectivity, we also look at the set direction. Yeah, that's what I'm gonna do right now. So if I attach volume rendering to original data like this, just make it more transparent, you adjust opacity. And after that, you can also link to the ROI box as well. So on the top of the volume rendering setting, you see the first tab. Click on this little white box again and select ROI and then attach to the ROI box. So now you have this. Yeah. 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 Yes. I think this have been done by first he was hired as intern and he created this kind of simulation in Nicola Cambore, and then now he been hired as the developer for this extension. So yeah. Yeah. Mhm. Yeah. 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 Mm-hmm. Yeah. Yeah. The what? Yeah. Mm-hmm. Yeah. Sure. With Dominic Bennett, maybe you know them. Yeah. And also some constraint as well. Mm-hmm. Yeah. But it's good suggestion. So yeah, we appreciate feedback before I can also convey this message to the R&D to improve it further. I mean, if you have any kind of comment, oh yeah. Yeah, I think there are a lot of explanation on everything, so you need to spend time and yeah, and the theoretical elements. You mean here? Yeah, it's actually with the experiment simulation. Yeah, so let me check. Yeah, no, but if you look at the user guide and I go to, let's say, extension, and extension here we have simulation. Yep, yep, XLab simulation. And you can see the absolute probability, molecular diffusivity, and so on to more connectivity. But if you look on the XModeling, we have more. On the digital rock, we have many. So this here you can see that for the module we have absolute probability tensor, and so on. Yeah. And just but you really welcome if you have more input, so I can give this feedback to the R&D to develop them. Yeah, sure, no problem. So I think this is mostly we just want to give some example what you can do with this module. So in principle, in Avizo we have different module, but we also have some tutorials so you can follow for the other example of simulation. And for the pressure component, you can just look at the magnitude. You can look at the height map slide by right click and select height map slice, and maybe I stop quickly the illuminate streamline, or you can maybe quickly turn off. So if I change this something, let's say temperatures, and you can again adjust the scale and overlay together how the pressure exert into certain region. Yeah. That's pretty much of the simulation. So yeah. Pardon? How to what? Just to show the pressure that are presented in, for example, if you look at the calculated on the channel of the process, it just visualize. I'm not sure it's that's important. And again, if you would like to look at this tutorial in more detail, if you can click on question mark here, we should have tutorials. Okay, go to tutorials, and in tutorials, so we have better go to the first extension. Extension, and select XLab, and you can see that absolute probability, and in theoretical data preparation, and so this is more like tutorial that you can get more information, and then finally go to the experiment simulation. So for example, here you ask about the pressure, so we just visualize the height map slide that represent the pressure field in experiment. Display. Okay. So in meanwhile, I will just look at this download. And I'll open the Avizo to go. So I will just install quickly the Avizo to go that will show you. Avizo to go, the view. And the rest is just not no more tutorial. It's just the thing you just work on the module itself. You can type on let's say like strange. Yeah. Yeah, so the two-phase flow is just like prepare data. It can be easily show you quickly what it's done. So yeah, can you show the screen? I don't know what happened there. I don't know what happened. Oh, okay. Yeah. So okay, then I remove this one. So to look at the two-phase flow, first you go to extra installer, as I mentioned in the morning, and you install the digital doc data. And once you install them, you can have this folder installed. So you can click open folder. Just do not change or modify anything in this folder because it's gonna affect everything. And from this folder of digital rock, open digital rock data, and in the two-phase flow simulation, so we have this data that we can do two-phase flow. So just open the data, drag and drop, and you can see this data. They have two materials segmented. We have the blue and red. So blue phase and red phase. We can also attach the auto slice. Another one. No, is it? Now we're gonna calculate the two phase. So like click and not sure why it doesn't appear here. Let me check quickly because it's supposed to. Tension. Yeah, so actually it's called Pore based PNM generation. Pore based PNM generation. And you have to select that multi-phase and its parameters. You can also select to generate property as well, but this gonna take much longer for base and again, if I check on this the two-phase flow in the rock sample, you can see this requirement. You need also the prepare for network module data, and you can just follow this step as well. And then what we do here, we can just load directly the example data. Yeah, two materials. Before we have only one material, but this now you have two materials. So we're gonna kind of generate the Pore network for the two materials, but it takes much longer, as you can see here. So if I click apply, it's gonna take a while to generate. That's why they prepare the already finished prepare data. Yeah. Not sure if it's gonna take much longer. So all the tutorial is like this. You just download the prepared data set and attach the module. And yeah, it's gonna take much longer. I think it can take up to 30 minutes for this data set like this. So, but yeah, there's a lot of things. I ran it and then they recommended like you need at least half an hour to run this. That's why I'm gonna open the finished data. It's already in the tutorial folder. So this one you can see the original data, and this is one that already been generated. But if you run it, it's gonna take a while. Or if you have different data, it might take much longer. And okay, need to maybe stop. how I can kill this process. And yeah, different from yeah. So now I go to project workroom, and instead of open that data, I already show you the finished results. Just right click and attach component portfolio view here, and then again, then you know what to do with the values. Yeah, let's say radius on compared to original data. Let's go to have now. Yeah, this is difficult to see because there's too many information. But the idea is just to the same thing you did with core network model, but previously you did one material, now we have two materials, and then we just apply the same principle. And yeah, you already learned to use this core network model view and then do the scaling and everything. Yeah. 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 Mm-hmm. Yeah, exactly. So you see that the prepared material is they have two materials. Yeah, but this one you don't have to separate them. Before we separate them just to see individual object in the same material, but this time we have two materials and they're not separated. You can see. So we just want to see directly the connection between the two materials. Yeah. Yeah. Okay. And the rest is if you go to the page and it's clearly say, for example, if you go to digital rock analysis custom extension, and I already give this quick overview that everything is deprecated, mean there's no further support, no further maintenance, so it's just it's end of life of PerGeos. So you can still use it as is. You can work on it, but there will be no further development on this experiment. For example, you see that like here, you talk about the absolute probability left performance. Okay, and you can see you can just use the module and then use this parameter, but yeah. Okay. Which one? The relaxation? Relax. Yeah. Okay. Oops. This one, right? This one. Yeah. 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 Okay. Yeah. For example, you can change to 0 and 2, you said. Okay. True. I understand. Yeah. Okay. Yeah. So mostly, I think you also need the MPI management in the Microsoft. Not sure if your computer have it, so that. But yeah, that's what I mentioned before. It's kind of deprecated, not supported anymore. Just to be aware of, but you can still use it at least. I don't have. Actually, myself, I never use it myself. Yeah. So just you aware of like what's the requirement and Microsoft MPI 10 required. And I'm not sure what the future will be. Perhaps you can develop further and then maybe propose to add extra, because when I talk about extra like this, so anything can be developed. You can see this extra page. So we're gonna have this on, for example, like if you talk about the ECT, your beam energy, whatever, then you can add this on. It's not the standard module in Avizo anymore. It's more like add on a plugin. So if you would develop something that would be useful, you can also propose to us. You can of course put on this kind of open forum. Python as well, or Pico, Loga, anything. So yeah, because here we have the Python API. You can also work with the Python directly on Avizo. But if you would like to do custom development like C++, you can go to expand, and in expand you can go to let's say C++. Yeah, so this is kind of, if you would like to develop something with, if you know C++. It would be easy for you, right? Yeah. 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 That's why it's a bit like you know, yeah. I think we almost, yeah, cover everything, and then so I want to show you quickly some other installation of Avizo to go. So you open it, and usually everything you have to accept it and open. So now you open Avizo to go. Imagine if you go on conference, you open it and open the project that I saved it previously. Open project, it's on desktop. Wait. And this the one that I just saved quickly. So it's come up like this. Yeah, of course there was some error because I used some module that is still beta function. But you will see everything as you have Avizo installed on your computer. You see the reviewer, you see the table, so you can clearly look at all the parameter that you work it. That's really useful. Even on the Pore network model, you can see which step that you are doing recently. I think this is really important, and then it's free. So if you have some colleague that doesn't have Avizo to go, Avizo license, you can ask them to install Avizo to go, and you send this project save as to go version, and you can show them exactly. You can even have to do some annotation, not sure, or you can create annotation in Avizo before you export it. So okay, this is point here that you want to look at. Yeah, I think that pretty much. I know it's a lot to digest, and yeah, I will come back again next year so we can maybe hope a better like stable version and to see more features. Is that okay so far? Yeah, yeah. And I still strongly recommend that yeah, try to look on the reference guide, and then I hope this would. Yeah, yeah, I'm fine. Yeah, no problem. Yeah. But thank you so much for, yeah, your attention. And I know it's hard, a lot to digest, and then some people might get lost in between. But I hope you just get familiar and try to work on it. And maybe Ronell can help you why he's here at some certain point. Oh yeah, with yeah. For example, maybe we are here. Let's just quickly show you this on the PerGeos one more time for profile. So open data and digital log for profile. Open sample, Volvo, So if you go to core profile, as I showed you yesterday and I mentioned to Ronnie already, it's more like a visualization. So visualize the core, the plug, and let's say like here and create the logs. Okay. And display all logs. Here you can do, let's say you want to create a report. Yeah, you can go to report and here you have to select for the snapshot. For example, I want to do this here. Click snapshot and then copy to reporting room. Okay. And okay. And then go to the reporting. So you can put this thing on the report. And then you can also analyze it. And something like this. So this is just quickly to show you how the reporting. I'm not sure is it useful enough for you, but yeah, you want to show some like log on the core profile. Like you want to see the log. You can so like export snapshot in the reporting, and then you can generate the report as a PDF. And you can, yeah. So you do this kind of table at the profile. So maybe and then even I'm not sure why it doesn't work with the image. Oh yeah, exactly. Right. So you can export many things in the report. Export it. Yeah, exactly. But it's just you can do it better. Yeah. Yeah. So yeah, that's all. And thank you for your attention. So later I'm still here this afternoon. If you have some question, maybe we can discuss.